All right, here we go. We're going to look at the quotient property of exponents. It's pretty straightforward. All that says is if I have a fraction and on those in the numerator and the denominator of those fractions, I have a to the m and a to the n, meaning I have two exponential equations and the bases are the same. All I have to do is subtract the exponents from the numerator and the denominator. So let's go ahead and look at an example. I've got 4 of them up there for us. It says a to the 12th divided by a to the 7th. Notice that the bases are exactly the same. They are a, so I can go ahead and write this as a to the 12 minus 7. And I know 12 minus 7 is 5. It is just a to the 5th power. Okay, I go to the next one. It gets a little bit more complicated. I am going to keep my fraction piece in there, because I do like to do that. And it says 6 divided by 3. I go after the easy things first. Well, I know 6 divided by 3 is 2. So I put 2 in the top of the fraction because it is a whole number. And then after that, I break it down and I say, okay, the bases of C are exactly the same. So all we got to do is subtract the exponent. So that's like saying 3 minus negative 5. Okay, well, 2 negatives make a positive. So that is 3 plus 5, which is 8. And I just write C to the 8th power. So we have 2C to the 8th power. Now we continue this. We go over to this next problem. It's a little bit more complicated. In fact, this one actually takes a couple of properties in there. So the first thing I'm going to do is I'm going to take that 2 over negative 4 and I'm going to simplify it. It's an easy thing to do. And I'm going to get negative 1/2. Once I do that, I'm going to go ahead and rewrite it with d to the 7th at the top. But I am going to use the power property right here. Okay, and if you remember, the power property says if the bases are the same and they're multiplying, you just add the exponent. So essentially what we have is d to the 9th times d to the 5th, which is the same thing as d to the 9 plus 5, which is 14. So I write d to the 14th power. But I'm not done because we still have this quotient property down here. And you're going to notice I have 2 bases that are exactly the same. So what can I do with their exponents? I can subtract them. So I'm going to write out that fraction one more time. I'm going to say 1 over 2 negative, and then I'm going to write d to the 7 minus 14. D to the 7 minus 14 is the same thing as d to the negative 7th power, d to the negative 7th power. Now, the tricky part that we need to remember is that negative exponents are going to move things to the bottom of that fraction. We learned that when we were talking about 0 negative exponents. So I'm going to write negative 1 over 2, and this negative exponent, okay, makes us put it in the bottom of the fraction. So I'm going to write d to the 7th power in the bottom of a fraction. So this is just simply negative 1 over 2d to the 7th power. So now we've got one last problem up here. And this is only complicated because it's got 2 variables in it, but it's not hard. So I'm going to write it right next to it, and then we'll start solving vertically. First thing I want to point out is we have this 9 over this negative right there. And that just means that we've got a negative 9. Let's simplify that just a little bit. Now we look for the quotient property. Quotient property says that if bases are the same, we subtract those exponents. Well, guess what? I have an x and an x, and the bases are the same, so we subtract them. What is 10 minus 5? Well, 10 minus 5 is 5, so I write x to the 5th power. After that, I go to the next one. I say, okay, I've got y to the 3rd divided by y to the 3rd. The bases are the same. So what do we do with the exponents? We subtract them, 3 minus 3. So we get 0. So we get y to the 0th power. But check it. Wait a second. What do we remember about anything to the 0th power? Anything to the 0th power is 1. So I can rewrite this as negative 9 x to the 5th times 1, or let's just clean it up. I'll clean it up right here. Negative 9 times 1 is just negative 9x to the 5th power. And we are done. That is looking good with the quotient property.